2016 interview, Elon Musk was asked whether we might be living in a simulation if an advanced civilization could create life through simulation. Musk responded that he believed there was only a 1 in a billion chance that we would live in the real world.
It would seem to follow that the odds that we're in base reality is 1 in billions.
In short, Musk thinks there is a high probability that we exist in a virtual world. Many might think Musk is exaggerating, but with the recent release of OpenAI's latest world simulator, Sora, a program that can generate lifelike videos from mere text, we are compelled to rethink this. As AI continues to develop, it will eventually create virtual worlds that surpass reality. When that time comes, the boundaries between these virtual worlds and our real world will disappear. Furthermore, if AI reaches its peak, it could simulate an entire universe and allow virtual life forms to experience what we call the real world. This leads us to ponder whether our current world, including the entire universe, is all a simulation. How can we prove that we live in a simulated universe? Today, let's discuss this thought-provoking and somewhat terrifying question. Before discussing whether we live in a simulated universe, let's talk about an experiment conducted by Stephen Hawking. The British theoretical physicist Stephen Hawking was keen on verifying whether time machines could be realized in the future. So, he wrote a letter and placed it in a museum, with the envelope stating, "To be opened only after the invention of time travel." The letter invited any future time travelers to visit him at the University of Cambridge on June 28, 2009 at 12 p.m. He promised to host a dinner for this time traveler and provided precise coordinates, keeping this event strictly confidential. On that night, Hawking waited nervously for the time traveler. As the clock approached midnight, the expected knock on the door never came. He was disappointed that his experiment had failed. This experiment suggests 3 possibilities. 1. Humanity never invents a time machine. 2. Time machines are invented, but they operate in parallel universes, and the Hawking of our universe did not meet the traveler. 3. Time travel is feasible, but humanity goes extinct before inventing it. Although the experiment was unsuccessful, it offers a new perspective on considering whether humanity exists in a virtual world. As early as 2003, Oxford University philosopher Nick Bostrom proposed the simulation hypothesis. He suggested that if our current world is a program simulated by a higher dimensional civilization, and we are just simulated characters within it, then we fall into one of 3 possibilities. 1. Humanity has advanced to its peak and now exists in a virtual form. We, in the present, are actually those future humans. 2. Future humans have developed virtual life forms, and we are living virtually while believing we exist in a certain historical period. 3. Future humans can create virtual worlds, implying that other advanced civilizations can also create virtual worlds. This would naturally lead to a vast number of virtual worlds being created. Our reality could be one of many nested virtual worlds, where virtual realities are within other virtual realities, possibly repeating infinitely. The number of virtual worlds would far exceed the number of real worlds. Suppose future humans can develop the ability to create highly realistic virtual worlds and manipulate human consciousness and memory. In that case, it strongly suggests that our current world is likely simulated by another advanced or higher dimensional civilization. The probability of this is either 0 or 100%. This is similar to the idea that if life like Earth exists in the universe, then the probability of other life forms existing is 100%. The universe either has no life or it has abundant life. Similarly, we are either real or we are in a multitude of nested virtual cycles. Nick Bostrom's core point is that if future humans can develop other virtual life forms, then we are almost certainly in a virtual world. The key to creating virtual worlds lies in how to simulate consciousness. So far, the origin of consciousness remains an unsolved mystery in science, philosophy, and artificial intelligence. Our understanding of the nature and mechanism of consciousness is limited. Scientifically, consciousness is often explained as the result of complex interactions between electrical, simulated, and chemical signals in the human brain. Some philosophers suggest that consciousness might be a fundamental form of existence, independent of the brain, rather than a byproduct of it. In the field of artificial intelligence, consciousness is seen as the product of information processing. In this framework, consciousness arises from a series of complex computations, and by simulating these processes, machines or AI might achieve a form of consciousness similar to humans. The human brain contains approximately 86 billion neurons, each forming connections with thousands of other neurons. While current technology struggles to simulate this level of complexity, advances in computing power may eventually allow AI to match or exceed the computational challenges of the human brain. Ultimately, this could lead to the creation of a godlike computer capable of simulating an entire universe. How powerful would this computer need to be? Our brains generate thoughts continuously. If we consider each interaction between neurons as a single computation, the brain performs about 10 to the 20th power operations per second, and this is just for one person. However, a simulation program would need to switch between different moments in time, so the computer must simultaneously simulate every human being and every historical moment. With approximately 100 billion people having lived throughout history, an average lifespan of 50 years, and 31 million seconds in a year, multiplying these values results in an astounding number. This godlike computer would need to process 10 to the 42nd power operations per second, surpassing the number of grains of sand on Earth. A supercomputer powered by a star would have sufficient computational strength to handle 10 to the 42nd power operations per second. Moreover, a computer harnessing the energy of an entire galaxy could effortlessly simulate the entire universe. This would be achievable for an advanced civilization, as long as they do not go extinct before reaching such a stage. British physicist Melvin Vopson has proposed an unprecedented experiment to unravel the age-old question of whether we truly live in a virtual world. He hypothesizes that if our physical world is a virtual system, then the fundamental information units constituting this physical world would be atoms, molecules, cells, and genes, down to the elementary particles of the universe. These elementary particles follow specific informational rules, such as physical laws, chemical reactions, and biological evolution orders. All this information would be set or modified by a higher-level information system or source, such as a super AI or a super civilization. Vopson's hypothesis is based on a new physical law known as the second law of information dynamics, or the information entropy law. This law states that the information entropy in an information system, or the degree of disorder of information, is a constant or conserved quantity. This means that information in an information system cannot be created or destroyed. It can only be transferred or transformed. Hence, Vopson believes that if our reality is a virtual information system, the basic information units should carry some hidden information. This information is crucial for the functioning of the system, but is encoded or encrypted by a higher-level system or information source for some reason. This hidden information might involve various parameters or variables of our reality, such as physical constants, initial conditions, and boundary conditions. Extracting or decrypting this information would be equivalent to finding the world's bug, proving that our world is virtual. His experiment involves using a homemade collider to smash a fundamental particle and its antiparticle together, such as an electron and a positron. This collision would cause them to annihilate each other, releasing energy in the form of photons. His task is to measure the frequency of these photons. If the frequencies are specific, it could indicate that these particles carry some hidden information trying to escape, potentially proving that our reality is a virtual system. In reality, everything we see, hear, touch, and smell is the brain's processing of electrical signals from the external world. What we touch may not be physical, as long as the brain perceives it as physical. This is similar to our experiences in dreams, where we do not interact with any physical entity but still experience a highly realistic physical world, which is just the work of neuronal electrical signals. The human brain operates on analog signals, but can be represented by digital signals. In other words, the brain is an analog signal that can be digitized. suggesting that everything in our physical world can be digitized or pixelated. Dr. Vopson argues that substantial evidence suggests that our physical reality might be a simulated virtual reality rather than an objective world existing independently of the observer. Any virtual reality world would be based on information processing, meaning everything in this world would ultimately be digitized or pixelated down to the smallest unit, 1 bit, which cannot be further subdivided. A bit is the smallest unit of information and can be considered the resolution of this virtual system, akin to the Planck length, the smallest scale of the universe, forming the most fundamental elements of the world. In physics, there is evidence that might support the simulation hypothesis. The speed limit of the universe, the speed of light. In reality, this limit is analogous to the speed limit of a computer's CPU. We know that an overloaded CPU will slow down a computer's processing speed. Similarly, in Einstein's general theory of relativity, time also slows down near a black hole. A massive celestial object, like a black hole, would slow down the speed of the universe's simulator. Recent developments in quantum mechanics, especially the work of the 3 scientists who won the Nobel Prize in 2022 for their contributions to quantum information, have further revealed the strange phenomenon of quantum entanglement. Quantum mechanics, a theory developed in the early 20th century, successfully explains the behavior of many subatomic particles. When the world and the universe are reduced to their smallest components, their behavior cannot be described by classical physics. One of the core features of quantum mechanics is its probabilistic nature, where the behavior of subatomic particles can only be predicted in terms of probabilities rather than certainties. For a long time, Einstein, a representative of classical physics, famously said, "God does not play dice," reflecting his belief that physical phenomena should have deterministic explanations, rather than relying on probability. This represents the division between classical physics and quantum physics. Quantum mechanics suggests that the world around us does not seem to be real. Particles in a definite state do not appear to exist unless we observe or measure them. Instead, they exist in a mixture of different states. Moreover, in quantum entanglement, 2 particles, regardless of the distance between them, will affect each other's state instantly when one is manipulated. This reaction occurs faster than the speed of light, even tens of thousands of times faster. This violates Einstein's principle of relativity, which states that information cannot travel faster than the speed of light. However, if the universe is a simulator, the virtual world's code should define all locations as roughly equidistant from the central processor, and accessing these points should be instantaneous. Therefore, while we think 2 particles are separated by hundreds or thousands of light years, if they are created in a simulation, this distance is effectively non-existent. If future advancements allow us to create sufficiently powerful supercomputers, it would be possible to simulate a complete and realistic world, including self-awareness. Consequently, it is plausible that we might be living in a simulator created by a cosmic designer. If this designer is akin to a player, they would likely refrain from excessively interfering with the evolution and development of life. Instead, they would set up the system with specific parameters and operational rules, observing whether the system can self-evolve into intelligent life or even a super-civilization. According to current theories, the emergence of carbon-based life in the universe requires sunlight, air, water, and an optimal distance from a star, among other conditions. We have discovered that both Mars and Venus once had water, and Mars is even within the Sun's habitable zone, yet neither shows any signs of life. This suggests that the system is stringent regarding the conditions for life's birth. Even slight deviations in temperature settings can prevent life from emerging. If the system were designed to support abundant life, the cosmic player's sense of accomplishment would diminish significantly. Earth, for instance, was struck by a planet, resulting in the formation of the Moon. This impact tilted Earth's axis, creating an angle that helps disperse surface temperatures evenly. While other planets also have axial tilts, none are as perfect as Earth's. This designer might have purposes and rules beyond our understanding. To conserve system resources, the designer could ensure that points on the map or scenes only appear when observed. The same applies when we observe the universe. If we are within a virtual system, the universe doesn't need to present all information constantly. This is similar to the game GTA 5, where driving from one neighborhood to another shows various people and objects, but in reality, nothing exists in the areas where we aren't present. This design reduces the computational load on the computer's CPU, analogous to quantum entanglement phenomena. We shouldn't be pessimistic about this possibility. If we live in a virtual system and can perceive the world beyond the system, then we are simulated. If we cannot perceive it, then we are real. Sometimes, the distinction between real and virtual is relative. If humanity cannot perceive what lies beyond the universe, even at extinction, we can consider ourselves real. Whether a system is real depends on whether the observer is inside or outside the system. Thus, man plans, God laughs, holds some truth. Our inability to explain what lies beyond the universe suggests that the answer is beyond our dimension, as an NPC in an infinitely large game map cannot perceive the player controlling the game. If an NPC suddenly realizes it is virtual and has evidence to expose it, the consequences would be